Hello guys, this is lecture number 12 on JEE concepts, and in this video we are going to solve 3 questions, and that questions will be related to questions up to Newton's laws, and this is 5th lecture in this regard. But here why I've written this up to Newton's laws, because in this video I'm also going to be discussing 2 questions on projectile motions. One from IIT JEE 2000 that came in IIT JEE 2000, and the other a little bit of complex question but conceptual question, and the remaining 1 question will be from non-inertial frame combined with tension on strings. So since this is a mix-up of questions, that's why I have named this as questions up to Newton's laws. Now let us begin. So the first question in this regard is, find the mass m, this is basically mass m, of the hanging block in figure, which will prevent this small block from slipping over the triangular block. This triangular block. All the surfaces are frictionless and the strings and the pulleys are light. So this is actually a combination of tension on strings, because here we are having strings, and non-inertial reference frame concept. Why? Because in this case, when this mass m will go down like this with acceleration a, then this is going to move with acceleration a forward. This whole system, like small m and m dash, this whole system is going to move with an acceleration a. So this block of small mass m is kept over this triangular block of capital mass m dash, and that's why this small mass m block is basically on a reference frame which is non-inertial, because this m dash mass is accelerating. That's why this is on a non-inertial reference frame, this small mass m block. We need to actually find this capital mass m so that the small mass m is not going to slip over this triangular block. So this is a good question from H.C.Verma, taken from H.C.Verma. So first of all, let me show the forces. Like for this capital mass m, it will be like mg over here and this tension over here, and for this system it will be like capital T over here, tension, and this acceleration is this acceleration is. Okay, so if I'm gonna write the equation for this capital M mass block, like for capital M, then it will be something like mg minus of tension is equal to ma. That is the first equation. And for this whole system, like small mass m and capital mass m dash, since it is already written in the question that we have to prevent the smaller block from slipping over the triangular block, so this all system will move together, and that's why I can just take this whole system as what? Of mass small m plus m dash, like this, and then the equation will be like force is equal to mass into acceleration, like this. This is our equation number 2. So these are the 2 equations. Now the complexity basically starts when you consider this small mass m as the system, because these two are actually different systems, m dash and small mass m. I have taken together because they are moving together in the forward direction because of this smaller block from slipping over the triangular block. It is not actually slipping over the triangular block, that's why. So now let me take this small mass m as the system, and let me show the forces on these 2 systems. So this is something like that, having an acceleration a in the right direction like this, and so if you take this small mass m as the system, then there will be a pseudo force, because the frame of reference in which this small mass m is basically accelerating, and that's why it is a non-inertial frame. So we have to apply a pseudo force. I have already discussed this concept in the previous videos, so just go through that. So the force will be like here in this direction, mass of this block and acceleration of this frame of reference a, like this, and this is angle theta. Another force will be mg, weight, like this. So just resolve the components of these forces in the direction parallel to the incline and perpendicular to the inclined plane, like this, perpendicular to the inclined plane, and this parallel to the inclined plane. So this is theta, this is 90 minus of theta, this will be theta, and this will be theta. Okay, so here it will be ma cos theta, and here it will be mg sine of theta, and here it will be mg cos of theta plus of ma sine of theta, and here it will be normal reaction. So perpendicular to the inclined plane, we don't have anything to do with the forces and the equation, but let me write, like n will be equal to mg cos of theta plus of ma sine of theta. That is the equation. Okay, and parallel to the inclined plane, the equation will be like this. This force is going to balance this force, and that's why this small mass m is at rest. It is not slipping because these two forces are balancing each other. That is the concept behind this question, that these two forces must be opposite to each other. So ma cos of theta is equal to mg sine of theta. Then only this block is not going to slip on this triangular block. Now this mm going to be cancelled. A is equal to is g sine theta upon cos theta, that is tan of theta. So this is the acceleration. Now we know the acceleration, this part, that is A is equals to g tan of theta. And what I need to find? I need to find this capital M mass. So for that I need T also. And for this T, I have this equation. So let me write this value of A over here to get T first. That is equals to M plus M dash. A is what? G tan of theta. Now we are having T. Just put this value of T and this value of A over here to get the capital mass M. So A we know, that is G tan theta. So just put this value of T and this value of A over here, and that will be equal to mg minus of M plus M dash G tan theta, that is equals to mg tan of theta, like this. So that can be written as mg 1 minus of tan of theta, that is equals to M plus of M dash G tan theta. So from here g cancelled out, M can be written as M plus of M dash tan theta upon 1 minus of tan theta, that is equals to M plus of M dash. Divide tan theta in the numerator and the denominator, and you will get cot theta minus of 1, and that is the answer. That is the capital mass M actually. So this is the manner in which you need to proceed when the question is related to the non-inertial reference frame. So now let us move towards the next question. So this is the next question which basically came in IIT JEE 2000, and this is a good question. So the question is, like an object A, this is the object, is kept fixed at the point x is equals to 3 meter and y is equals to 1.25 meter, like it is given over here, on a plank P. This is the plank raised above the ground as it is shown here. At time t is equals to 0, the plank starts moving along the positive x direction, this plank as shown over here, with an acceleration a is equals to 1.5 meters per second square. This is basically the acceleration of plank P. At the same instant, a stone is projected from the origin with a velocity u vector as shown, like this. This is basically the stone over here. This is what? Stone that is projected with a velocity u vector as shown. A stationary person on the ground, suppose here, observes the stone hitting the object during its downward motion. Okay, suppose this stone is going like this and like this, and this is moving like this. So this stone basically hits this object A when during its downward motion, like over here, because it is rising up to its maximum height like here, and then it is moving downward, this stone. And when this plank P or the object A reaches here, suppose at point Q over here, then this stone also reaches this point Q, so that this stone hits this object A, like it will be something like here, plank P and this object A. So this is the point of collision. This is the point where both stone and this object A meets at point Q. And this is also the downward motion of the stone at an angle of 45 degrees to the horizontal. Okay. At this point, the velocity, which will be something like this is making an angle of 45 degrees with the horizontal, this u vector. Velocity at this point. This will be not the same u vector as this, so let me write u dash vector. All the motions are in xy plane. Find u vector and the time after which the stone hits the object. We need to find two things, u vector and the time. So what are the things that came to your mind after reading this question? Two things. One, the motion of this stone, and the other thing, the motion of this plank P in which the object A is kept. Now the acceleration of this plank P is given, and initial velocity of this plank is basically 0. And let us suppose that at time t it reaches at point Q. From this point, say P as it written over here, this plank P at point P, just suppose. So from P to Q, it takes us T time for this plank or this object A to reach from point P to Q. Then at point Q, the distance PQ actually, x PQ, will be equal to this distance I'm talking about. This can be written as x is equals to ut, u is 0, ut plus of half at square. This is 0 because u is 0. That is equals to half into a is what? 1.5 into t square. That is equals to 0.75 t square. That is x pq. Okay. The first thing that we have now. This is the x pq. And for this stone to reach over here at point Q, the x is basically, this x is basically how much? This is 3 up to here, this is 3, and this is x pq. So 3 plus of x cube pq, that is 3 plus of 0.75 t square, that is x for stone. Okay, stone has to travel this much distance in order to reach at point Q in the same time t for this A object and stone to collide. And with the perspective of projectile motion, because stone is a projectile, what will be the x? X is equals to ut, like uxt, plus of half at square, but acceleration is 0 for the projectile motion in the x direction, that we know. So x is equal to what? U is u vector, that is u cos theta multiplied by t, and that is equals to what? 3 plus of 0.75 t square, this one, because we have already calculated x for stone, that is 3 plus of 0.75 t square, and 0.75 t square is what? X traveled by this plank P. So we have this now. Now the other thing is, this is basically regarding the x direction distance. The other thing is y direction, the height for plank P is not going to change. It will be 1.25 only, 1.25 meters, because this plank P is moving in a straight line and stone is going to hit at that same y, that is y is equals to 1.25 meters, and this stone is going to hit at same y, that is 1.25 meters. So let me write another equation for projectile motion. We know that y is equals to uyt minus of half gt square, and uy is what? U sin theta multiplied by t minus of half gt square, and that is equals to what? That is equals to 1.25. So this is the another thing that we can write. Now the third thing which we can write is related to this 45-degree angle, because it is given that stone hitting the object during its downward motion at an angle of 45 degrees to the horizontal. So that I can write by using v is equals to u plus of at in the y direction. So vy, we need to find vy, and that is equals to uy. Uy we know, u sin theta in the positive direction minus of ay is gt, that we know. Okay, this is the equation. But now what is vy? Well, for calculating vy, we have already assumed the velocity here as u dash at this point q, and at point O, this is basically angle theta. So x direction velocity is u cos theta and y direction is u sin theta. But we also know that x direction velocity for a projectile motion is not going to change, it is constant. Why? Because in the x direction the acceleration is 0. So x direction velocity is what? U cos theta, and that is equals to the x direction velocity at this point q over here. And what is that? Well, that will be u dash sine or cos of 45, because 45 is same either for sine or for cos, that is 1 upon root 2. So that will be equal to u dash upon root 2. This is u cos theta. So from here u dash is what? That is equals to root 2 u cos theta. So y direction velocity will be what? That will be again u dash cos 45 or sine 45. That will be y direction velocity, because the values are same, and that is equals to root 2 u cos theta upon root 2. This cancelled out, and remember this is in the negative direction because now this stone is going downward. So x will be positive but y is negative. So that is equals to u of cos theta, negative of u of cos theta, and that is the y direction velocity at point Q, which is what? Which is this vy. So this is the important thing to know. You need to find a relation. Otherwise you're gonna get confused if you write it directly. So let me write again this equation, that is Vy is equals to u sine theta minus of gt, and Vy we found is what? Minus of u cos theta, that is equals to u sine of theta minus of gt. The other two equations that we are having are this and this, as we have found. So from here I can write this as u sine theta multiplied by t is equals to, g is actually 10, that is given in the question, so that is 5t square plus of 1.25. So now we are having this, this and this. So we are having u cos theta multiplied by t and u sine theta multiplied by t. Here we are having just u cos theta and u sine theta. So just multiply this equation with t, and that will be u cos theta multiplied by t is equals to u sine theta multiplied by t minus of gt square. So just put this u cos theta multiplied by t over here, that is minus 3 plus of 0.75 t square, that is equals to u sine theta multiplied by t 5t square plus of 1.25 minus of 10t square, because this g is nothing but 10. Just take these values over here like t square over to the left side and 3 to the right side, then that will be 10t square minus of 5t square minus of 0.75 t square, that is equals to 3 plus of 1.25. So this is what 5 minus of 0.75, that is 4.25 t square, that is equals to 4.25. So from here t square is equals to 1 or t is equals to 1 second, because time cannot be negative. So this is the time after which the stone and the block A, object A, is going to collide. That is the time. So the time at which the stone hits the object is t is equals to 1 second. So this is just the relationship that you need to find. You just have to use the x direction equation, y direction equation, and the one thing extra that is given in the question. At 45 degrees the stone hits the object when the stone is coming down. So these three things you need to use. Now the other question is find u vector. You need to find this u vector. Well, we can find u vector from over here. This is the x direction velocity and this is the y direction velocity. You just need to put the time over here. So let me first use this, then u cos theta, t is what, 1 second, that is equals to 3 plus of 0.75 multiplied by 1 square, that is equals to 3.75. that is the x direction, so I cap. Similarly for the y direction, this thing, u sine theta multiplied by 1, that is equals to 1.25 plus of half into 10 into 1 square, and from here it is 5.25, that is in the y direction, j cap. So the velocity is basically 3.75 I cap plus of 5.25 j cap, that is the u vector. So this is the answer. So now let me move towards the next question. Well, this is a conceptual question, and the question is like a projectile is launched from point A, this point, with the initial condition shown in figure, like this u vector at 68 meters per second, that is the magnitude, at an angle of 30 degrees. And over here this is a quadrant like this, having radius of 150 meters. We need to find the x and y coordinates of the point of impact. This is the point of impact, this over here, say Q. We need to find the x and y coordinate for that. Well, at first when you see this question, then you're gonna get confused. That is obvious, because you don't know how to proceed for these kind of questions. In this question, you're gonna need to think somewhat different than the conventional questions of projectile. Here we are having this quadrant, which is a part of some circle, and this projectile, and you need to find some coordinate that is on this circle, like a quadrant which is a part of a circle, and you need to find the point of intersection of this projectile and this circular part. So when you need to find a point of intersection between two different curves, then at that point of intersection the x and y coordinates of both the curves must be equal, and that is the concept which we are gonna use over here. So for that, let me write the equation of circle and the equation of projectile, like trajectory of projectile, equation of trajectory for projectile. So for circle, we know that x coordinate of the center, this is the center of the circle, and x coordinate is 300, that is given from this origin, and y coordinate is 150 from that origin, and radius is 150, that we know. So from there I can write the equation of circle is x minus 300 whole square plus y minus 150 whole square, and that is equals to 150 square, that is the radius square. So that is the equation of the circle. Now for equation of trajectory of a projectile, we already know that y is equals to x tan theta minus of half gx square upon u square cos square theta. That is the equation of trajectory for the projectile. I have already derived it in one of my previous videos, so just go through that. So using that, the other equation will be y is equals to x upon root under 3 minus of 2x square g upon 9248. Actually you just need to put all the values, like tan theta is 30 degrees, and again for u and cos theta. So after putting all those values and solving, you will get like this. So this is our equation number 2 and this is our equation number 1. Now you have two equations and two unknowns. Only x and y are unknowns in these two equations. So we are having two equations, two unknowns. So just solve these equation and ultimately you will get x is equals to 373 meters and y is approximately equal to 18.75 meter. So that is gonna be the x and the y coordinates of point of intersection, that is at Q. So this is how you need to proceed. This is how you need to attempt these questions and solve these questions, because this is basically a mathematical question related to the concept of projectile. So you just need the trajectories equations for these two different curves like circle and the projectile, and just you need to find the x and y accordingly. So this is all about this video, guys, and this is the end of chapter 5, that is Newton's laws of motion. In the next video we're going to start the friction chapter, and obviously the concepts related to this Newton's laws will be used in the future lectures also, but only a extra concept of friction will come in the questions along with the questions of Newton's laws of motions and some more different questions that we are going to see. So till then, thank you.